Okay, looking at radical equations, I'm going to see if I can simplify on either side of the equation first. I want to isolate the radical expression, and then I can square both sides to get rid of the radical, and then you can always double check your answers. And you need to double check your answers every time. It's possible that one of them will not work. So the first thing I want to do is I want to isolate my radical, and I want the only thing to be over here is the square root of x, but I also have 11. So I need to get rid of that, so I'm going to subtract 11 on both sides of the equal sign. So I'm left with the square root of x is equal to 10. So then I need to get rid of the radical. I want to solve for x. So to get rid of it, I square both sides. So that gives me x equal to 100. So I'm going to go ahead and check my answer. You always double check your answer. So I have the square root of 100 plus 11 is equal to 21. So I put it back in the original equation. Square root of 100 is 10. And 10 plus 11 does equal 21. So yes, I got it correct. Okay, let's try another example. First thing I want to see, is there anything else on this side of the equal sign? And there's not. Okay, so since I have nothing else on this side of the radical, what I'm going to do to get rid of it is going to square both sides. So right here is where people will make the mistake. So what I need to remember here, squaring something is something multiplied by itself. So it's 2 radical 3 times 2 radical 3. So over here, squaring it will get rid of the radical. Here, I'm going to get 12. Now let's think about where we get 12. So 2 times 2 is 4. 3 times 3 is 9. Square root of 9 is 3. So 4 times 3 is 12. But again, hopefully you'll remember the square root of something times the square root of something is that number. So then I simply add 5. So I have x is equal to 17. Let's check the answer. So square root of 17 minus 5. So I need to get 2 radical 3. 17 minus 5 is 12. 12 can be broken down into 4 times 3. Square root of 4 is 2. So yes, it does work. That is correct. Alright, now looking at this one. So I need to check, do I have everything on this side of the radical by itself? Do I have the radical isolated? I don't, because I have this plus 4 here. So I'm going to subtract 4 on both sides. Now to get rid of the radical, I need to square both sides. Remember, to square means to multiply by itself. So that means I'll do distributive property 2 times. So x minus 2 is equal to x squared minus 8x plus 16. Remember, this is one of the special products we talked about. Now in order to solve, what I need to do is get everything on the same side. So I'm going to add 2 here, subtract x. So 0 is equal to x squared minus 9x plus 18. Okay, so now I need to factor this in order to solve. I mean, that's one way of doing it, if you can factor it, what we've gone over. So it's a trinomial, it's quadratic, a is equal to 1, so I can go straight to my answer. I need things that will multiply to equal 18 but add to equal a negative 9, and that's negative 6 and negative 3. Negative 6 plus negative 3 is negative 9. Negative 6 times negative 3 is 18. Now I still haven't solved it because I need something to equal 0. So I'm multiplying two factors here, this parenthesis and this parenthesis. The answer is 0, so one of these has to be 0. So x is either 6 or 3. Now you need to check your answer. Go back to the original and see if it works. So I'm going to do that up here. That's if it happens to be 6. This is if it happens to be 3, so let's see if it works. 6 minus 2 is 4. Square root of 4 is 2. So 4 plus 2 does equal 6. So 6 works. Now I'm going to try 3. 3 minus 2 is 1. Square root of 1 is 1. 1 plus 4 equals 5. Does not equal 3. So 3 does not work.